Okay, number 91. First you got to kind of understand this problem. Okay, we've got these two ropes. Okay, and they're tied to at some point here and some point here, and there's a weight attached right here in the end of 2,000 pounds. Okay, now in order to keep this weight from slowly accelerating down, you have to be able to counter that weight in the tension of these ropes straight up with the exact same magnitude. Okay, now this vector is pulling this way, and this vector would be pulling this way. So, so these two vectors that are going left and right, the blue and the orange one, are going to completely counteract this 2,000 pound vector going straight down. Okay, but it can't. This one can't be 1,000, and this one can't be 1,000 because because they're pulling at angles. If they were pulling straight up, if we had two ropes pulling straight up like this, then they could both be 1,000, and that would completely counteract this one at 2,000 pounds. But they're pulling at an angle. So they're wasting some energy going this way and this way. So they have to compensate for that by pulling more than 1,000. When we add these two together, okay, their y components up and down will be equal to this y component going straight down, but they're also going to have some x components added in. Okay, it's all a matter of physics, really. So how do we do this problem? Alright, so first thing we're going to do is we're going to analyze and move things around. Okay, so we have two vectors here that are somehow going to eliminate this vector going straight down. Okay, well, if we add vector, and we'll call them vector A and vector B. If I add vector A with vector B, remember tip to tail, they will be completely equivalent to this 2,000 pounds, but they're going to be going in the opposite direction. So 2,000 pounds, if I draw it straight down, looks like that, but if I draw it straight up, it looks like that. And then I'm going to move vector B from here to here. Okay, so now vector B, I just moved it from tip to tail, moved the tail to the tip here. Okay, but when we do that, let's try and figure out what the angles are. Okay, so what was this angle here before we moved? This one here was 50. Okay, this angle here is 30. What would this angle be down here? Okay, well, if this is a parallel, these two lines here would be parallel, so this angle would be 30. So this inside angle is 30, which makes this whole angle 80. Okay, and what would this angle on this side be? Okay, if this angle is 30, these two should add to 90 degrees, so this angle would be 60, which would make this angle up here also 60. So now we have 80, 60. We should be able to find the other angle down here. 80 plus 60, and if I subtract 180 from that, I get 40. Okay, so now we have a triangle here. We have 80, 60, 40 triangle, and this side is 2,000 pounds. Okay, so we should be able to find vector B and vector A by using law of sines. Okay, we'll do vector B first. Vector B, so if I take sine of 80 over 2,000, so this over this should equal sine of 40 over the magnitude of b. Okay, and let's set up the other one too. This should also equal the sine of 60 over a. Alright, so now you can put both of these two into your calculator. Take 2,000 sine of 40 divided by sine of 80. That's 1,000, so B would equal 1,305.4 pounds. And then the other vector would be 2,000 sine of 60 divided by sine of 80. A then would equal 1,758.8 pounds.